In this video, we're going to introduce the basics of Newton's third law. Newton's third law is usually stated fairly simply that for every action, there's an equal and opposite reaction. But what does this mean? It means that for every force acting on an object, there's an equal force acting in the opposite direction. So right now, if you think about it, as you're sitting in your chair, gravity is pulling you down in your seat, but then according to Newton's third law, your seat is pushing up against you with an equal force. So what happens if you're standing on a skateboard or a slippery floor and you push against the wall? Well, you're going to slide in the opposite direction, away from the wall, because you pushed on the wall, but the wall pushed back on you with equal and opposite force. Why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. So the harder you hit your toe against the rock, the more force the rock exerts back on your toe, and the more your toe is going to hurt. Now, another way you can look at this is you can't touch without being touched. That's Newton's third law. You can't touch something without it touching you back. So when we're talking about Newton's third law, or when we're talking about any force, forces always come in pairs. Think about it. If you take your hand and put it on the table, you touch the table touches you back. You pick up a pencil, you touch the pencil touches you back. All forces come in pairs. Newton's third law involves something that we call action-reaction forces. It always involves two objects with forces that are paired, and we call those action-reaction pairs or action-reaction forces. The two forces are equal in magnitude, but they are always opposite in direction. So a way of saying this is the hammer hits the nail hits back on the hammer. So when we are trying to identify action-reaction pairs, we can use the format that you see down here. And so when you do your homework, you want to use this exact same format. So what we're going to do is we're going to write the object 1. So if I have a book sitting on a table, I'm going to call the book object 1, and the table is going to be object 2. And so when I write out my action-reaction pairs, object 1 is the book. So the book, and usually this is going to be pushes or pulls, so you just choose one. So the book is pushing, not pulling. And what direction? It's pushing down or downward on the table. So this is the first force. You could call this the action force. The book pushes down on the table. Now, what's the opposite? Basically, you are going to switch your two objects and change your direction. The table, the force is always going to be the same. So if one's a push, the other's a push. The table pushes up on the book. So this is how you phrase your action-reaction pair. So let's do another one. So we're going to say we have the cart, we have the horse, and I'm going to say this one is object 1, this is object 2. So the cart pulls backward, or pulls back on the horse. The horse, pulls forward on the cart. Let's try another one. So this time we have let's say the foot, and we have a skateboard. We'll say the foot is 1, the skateboard is 2. So the foot pushes, and the foot is pushing backward on the skateboard. And if the foot is pushing backward on the skateboard must be pushing forward on the foot. So the skateboard pushes forward on the foot. This is actually how you walk also. So if you are walking on the ground, your foot pushes backward on the ground and the ground pushes forward on your foot. Okay, we have, this one's a little bit complicated if you think about what's actually happening. So we're going to say we have the gun, and what is the gun pushing out? Well, it's pushing these gases. So the gun pushes forward on the gases. The gases push back on the gun. And it's not really the bullet. You actually have the explosion that's going on inside. And so it's actually the gases that are pushing forward on the bullet. So this whole process right here that we've written down, this is what recoil is. So if you've ever fired a gun, seen a gun fired, when it kicks back, that's recoil. And it's because the gun pushes forward on the gases and the gases push back on the gun. All right, here we have a rocket. So again, we have our rocket, and then here we have gases. Notice whenever there's an explosion, we're usually going to be dealing with some kind of gases. So we'll say the rocket's 1, the gases are 2. So the rocket pushes back on the gases. The gases push forward on the rocket. Now, one thing to be careful of, if you've ever thought about a rocket launching, if say you have the ground here, the rocket is not pushing directly against the ground, and so the ground is not making the rocket move upward. All of this has to do with the rocket pushing the gases out and the gases pushing the rocket forward. Because even when the gases aren't in contact with the ground anymore, they are still propelling the rocket forward. Now, what happens when you try to push something and you're pushing with more force than it can respond with? Well, what's going to happen is that the object's going to change its motion. Now, both objects are actually going to change their motion, but the one that can't push back as much is going to change its motion the most. But no matter what, those forces, those action-reaction forces are the same. So let's go ahead and try a couple of questions, a couple of multiple choice questions. So pause to read the questions and try and answer each one before you listen to the answer. So a small car gives a truck a push to get back into town after it breaks down. As the car is accelerating, what happens? Go ahead and pause and read your answer choices. So looking at your answer choices, a small car gives a truck a push to get back into town. And as it's accelerating, if we look at the answers, what is happening between the forces? The amount of force the car applies to the truck is the same as the force the truck applies to the car. The amount of force the car applies to the truck is smaller than the force the truck pushes back on the car. The force the car applies to the truck is larger than the force of the truck on the car. That's why they can move forward. Or the truck is pushed forward simply because it's in the way of the car. There is no force. Well, remember, Newton's third law means that the car, the car is, I lost my pen. The car is pushing forward on the truck is pushing back on the car with the same exact force. That's A. It's Newton's third law. Next question. A truck collides head-on with a small car. During the collision, A, the truck exerts a greater amount of force on the car than the car exerts on the truck. That is why the car gets more damage. B, the car exerts a greater amount of force on the truck than the truck exerts on the car because the truck is more massive. C, the car exerts the same force on the truck as the truck exerts on the car. D, neither exerts a force on the other. The car simply gets smashed because it's in the way of the truck. Pause and think about your answer. And the answer again is going to be C. The car pushes forward on the truck pushes back on the car. Newton's third law means these forces have to be equal and opposite. Okay, when the fly hits the airplane, which will feel a greater force? A, the airplane, since it is more massive, it will experience a greater force. B, the fly, the airplane is much larger, so it will apply a greater force to the fly. C, the force of the fly on the airplane is too close to zero to count. Or D, they both will experience the same force? Think and answer. And of course, the pattern should be clear now, but the answer, whoops, the answer is going to be D. They both will experience the same force. The fly hits the plane hits the fly. Newton's third law says those forces must be equal and opposite. So now let's try this one. I know the answer was D because that's Newton's third law, but A, I don't get it. B, I can memorize it, but I don't really believe it. Or C, I get it. So think about your answer. Now, let's explain exactly why this works. So going back to that slide where it talks about what happens when you try to push an object with more force than it's able to respond with. So we're saying that the forces are the same. And remember that Newton's second law is force equals mass times acceleration. Well, we're saying that each of these is experiencing the same force. So the force has to be the same. And it's going to equal the mass of the airplane times the airplane's acceleration. It's going to equal the mass of the fly times the fly's acceleration. Well, think about the mass of these two objects. The fly has a really, really small mass. The airplane has a really, really big mass. So to keep them the same, so that the force is equal, what's the acceleration going to be like for the fly? It's going to be really, really big. What's the acceleration going to be like for the airplane? Very, very small. So if you think about what this means, is the change in the airplane's motion is going to be so small it doesn't even notice it. But the change in the fly's motion is going to be so big that it's smashed, that the fly is dead, the fly is decimated. So the airplane and the fly experience the same force, but that force affects them differently. The same force is enough to smash the fly, but not even phase the airplane.